Okay guys, so I thought I'm going to walk you through a bit of code here, some very simple stuff just to kind of illustrate my mindset about abstractions and functions and the way that I like to think about them. So we have a function called dog here that returns an object with a name and an age, and then we have an array of dogs, Spot, Fido, and Lassie with all different ages, and then we have a piece of code here that's going to get the youngest dog, which is going to be Spot with an age of 1, and log that out, and one for the oldest dog as well. So if I run this, you can see that it logs out Spot and Lassie, which is exactly what we expect. Now, what is wrong with this code? In essence, there's nothing wrong with this code. This is very common code, I would say. It's something that you see quite a bit. But what I don't think is so great about it, and I think we can improve on, is that we are redeclaring this piece of logic down here. Like this find function is using hard-coded logic. And even though this logic is very, very simple, it is still not. It's still hard-coded logic, and the way that a lot of, like, especially in object-oriented programming, I mean, you have the concept of interfaces or protocols, and I argue that this is the same type of situation. Why would you, if you can abstract this logic here and make it reusable and more testable, why would you not? Even does it really matter how trivial it is? So if I do this, dog with age 1, dog with age 1, what happened here is that all I did was to give it a named function, and I argue that this is as descriptive as this, even maybe a little bit more descriptive. If I read this, my youngest dog, dog.find dog with age 1. That's it. I don't have to read the logic, because as soon as you, like, if I'm skimming this and I'm trying to find some like just get a general sense for what's going on here, this to me is actually, I mean, this might have been as readable, but imagine that the logic changed. Imagine it became something more complex over time. Well, then I would have to go and update this lambda function in all the places where this logic is happening, or, you know, you see kind of where I'm going with this. I don't see that there's no real value in keeping it as a lambda function, but there is a tiny bit of value by making it a name function. So let's do that. And let's do this as well. No, actually, let's do that and that. 3, like so. Dog with age of 3, and we run that. Yeah, same output. So all we did now was to make a lambda function into a name function, and I think that, you know, the value is maybe a little bit negligible, but, you know, it's still, in my opinion, better than creating a lambda function. And here comes the next thing that I can identify by looking at this code. I can see that there is a common pattern in the way that we are making this evaluation. So we're taking the age property of this dog object here and comparing it to some number. So let's make a higher order function with age func, which is going to take in a number, return a function like this, and do the number comparison like that. What just happened is that, okay, so we create a function that takes a number and returns a new function that's going to compare the age property on any passed in object to that number. So now we can do this. Make dog with age 1 with age 3. We run that, and it should, yep, outputs the same thing. So what just happened is that we reduced, like, even though there's a very small chance that this logic, if we duplicate this logic over and over and over in different parts of our code, even if this logic is very simple, we get two things. We get more testability and readability and maintainability, because we have an abstraction on top of this logic. And second part is that we have something that will scale over, like we have something that will work the same way always. Like this is this way of writing the code is close to 100% accurate regardless of where you use it. And once again, remember, if the logic changes over time, this is going to be much easier to maintain. So I'm trying to just kind of sell you the idea that you shouldn't think about abstractions in terms of how big is the problem that I'm solving. Does that, I mean, it shouldn't matter if you're trying to do this trivial little thing, or if you're writing a function that's 300 lines of code long. That doesn't matter. What matters is that there is logic that you can abstract into a name of some sort and describe what the logic is doing, and then you can document the function and do all that good stuff, so that you can remove the requirements for me, who is the person who's going to read this code or use your code. I don't have to know how you solve the problem. Only if your function or the abstraction that you made is causing me some type of problem, or I need to actually know exactly how it works, do I have to care about it. But if I'm not looking at this specific function here, maybe I'm looking over here, or maybe down here, I don't care what's going on here, then if you just keep this information away from me, that makes my life a little bit easier. Anyway, then we'll see that, okay, so we've made some improvements here. What else could we do? Well, my youngest dog here, so it basically has a global reference to my dogs up here, and I think we could improve this a little bit as well. So let's see if we can do something like const. What could we do? We could do something like find the youngest dog, and that takes in an array of dogs and does this. Something like that. And then we do find the youngest dog, my dogs. Let's see if that works. Yeah, works perfectly, right? And all of a sudden, I removed this piece of logic here, array of dogs dot find. This logic here now is gone, and all of a sudden, all I know is that there is this magic function that takes an array of dogs, and it's gonna find my youngest dog. That's all I need to know when I'm consuming this. So let's do the same thing here. Find the oldest dog. Fine, and then we'll do that. Find the oldest dog, my dogs, like that. Let's see here. Yep, same output. Do you see where I'm getting with this? Like, little by little, I am abstracting and creating like a composable, layers of abstractions that remove the need for me to know how I'm solving this problem from the top level, but I'm still making sure that, you know, I'm basically trying to make the code more readable and more reusable without adding extra complexity. I mean, if I could do something like, I don't know, I could wrap this thing here in another function, and something you should never do, in my opinion, is something like, let's do foo, and it takes some type of value and then returns bar of some value. So bar doesn't exist now, but this is something that I think is this is an anti-pattern. Like, don't create a function that all it does is like call another function or a series of other functions, because then you're not providing any, like, then there's no value to, in my opinion, there's not much value to the function, because it's not solving any problems. It's a convenience way, in essence, for you to call a series of other functions. It's not something I'm completely married to, but like, I don't like to do that in general. So this is kind of the way that I abstract these things away. Now we can do something that's even cooler, which is this thing here. And this is like, I'm not saying that this is the way to go, but you can do this. So let's do const make find the dog func, and it's going to take in a function, and it's going to return this thing here. So what we're saying here is that, hey, I have a function now that's going to take in another function, and it's going to return a function that takes in an array of dogs, and then it returns array of dogs and does a find with that function. So what's going to happen now is that I can do this. I can do that. And I can do that. Let's see if it works. Ta-da! And it worked. And all of a sudden, we have reduced our duplication down to what I think is probably the smallest amount of duplication that we can make. And we did it in this is a very functional approach to solving this type of problem, and I highly encourage you to start thinking in this way, because remember, like my motto is that the true challenge to good software development is very rarely like optimization and performance and that stuff. It is about handling complexity over time, and this is I think a less complex way. I mean, it's not a simple thing. I mean, if we want simple code, then shit, just don't care. Just write code that makes perfect sense to you, because it's easy for you to write that code. And we need to make a distinction, in my opinion, between easy code and simple code. I think that consuming these functions and the way that we've structured this logic is simple, because it's easy for the consumer of this and whoever's going to maintain this code to maintain this code, but it's not as simple to write for me who's writing it right now. But remember, usually you write your code once and then you maintain it over time. That's generally the rule. So I think that it's a good practice to invest a little bit of thought into the maintainability of your code. Now, if we wanted to make this more maintainable, unfortunately, since we're in JavaScript, we could do all kinds of type checking, because right now, let's say that we're iterating, like if I remove something here, like let's say I add a null in there, boom, it blows up. And the reason why this is blowing up is because we're down here assuming that there's going to be an object with the age property on it and stuff like that. So we can start thinking about, type checking, making sure that, that we're actually getting the value that we are expecting and that it has an age property. We can make this even more robust and even better, but I just wanted to illustrate my thought process when I'm refactoring code, and the way that I hope I'm inspiring you to start thinking about your own abstractions.